Hello, hello, hello. And I am super thrilled to say hello and welcome to everybody to yet another OTel deep dive. Well, yet another. We've only done one in March of this year, and it was Mike and myself that time as well. But yeah, let me just enjoy and savor that for a second. But yeah, just want to say hello to everybody and super thrilled to see so many of you sign up. We've had well over 100 or so signups, even close to 150 for the webinar. So we are really, really thrilled to see the interest. And yeah, it tells us a lot about we should probably do some more of these hotel deep dives moving forward. But yeah, for me today, I am going to be your host, Adnan. I do developer relations here at Bindplane. And I have Mike, the Bindplane CEO and OpenTelemetry powerhouse here with me today. So he's going to be doing all of the fun stuff around OTel, and he is quite literally the go-to guy that I ask as well. So yeah, so Mike, say hi and introduce yourself.
Well, thank you. Yeah, like Annette said, I'm Mike. I'm the CEO founder of Bindplane and have been involved in OpenTelemetry for quite a while now. Definitely, with Bindplane, we built Bindplane on top of OpenTelemetry, and this is a really interesting topic to me. I love talking about OTel resiliency, high availability. It's one of the things that after you get through the hello world piece and you start to deploy, this becomes the most critical thing that people are thinking about. So appreciate everyone joining and look forward to jumping into this and talking about it. And Adnan's got some great demos, so do some deep dives as well. Maybe I'm skipping ahead. I'll let you go to the next one, Adnan.
No, this is great. This is great. We are definitely on point and on topic. But yeah, we want to be as respectful of your time as possible. So for the agenda for today, we've been trying to be as efficient as possible with the demos and the steps regarding what we want to teach you for today. Essentially, we do want to learn. I mean, we want to teach you, and you want to learn by the end of the hour to get high availability in 3 steps. So we'll show you the agent gateway pattern with the collector. We'll talk about load balancing, the different ways you can achieve load balancing. And then we'll also cover resilience, so specifically resilience in the OTel collector. All of the demos we're going to be showing today will be with both Docker and Kubernetes. Specifically, the Docker demo is transferable if you have a VM only setup as well. So the showcasing of the demo for Docker specifically, if you want to run that with dedicated VMs, it's totally fine as well. And then, of course, Kubernetes will be the cherry on top for auto scaling and some of the cool, more production ready setups that you might have. And then by the end of the hour, we really want you to take away these 3 main things. So you'll learn how to set up a pipeline with no data loss. You'll have very specifically set up telemetry continuity, and you'll also learn how to have horizontal scalability as well, specifically for your collectors. And with that, I am going to hand over to Mike to talk a bit about these more important concepts to get everybody on the same page regarding pipelines and how to build reliable pipelines.
Yeah, and I'll talk a little bit about the theory behind it and the architecture, but I think some of this is obvious, right? We know once you build out a pipeline, once you have your apps instrumented, um, you really have to treat this as critical infrastructure. And the big concern is what happens when this breaks. So how does this fail? How do we prevent that? Because we know as a piece of critical infrastructure, you're missing telemetry, you're missing the root cause. You may be breaking compliance requirements that you have. And so once we get through the first stage of we have this deployed, we have this in a POC, we've proven it out, we know the benefits of OpenTelemetry, we know the benefits of pipeline. We really need to think hard about how do we deploy this in a way that is resilient, that is allows for high availability and can guarantee a level of delivery. And so that's what we're going to talk about today. I'll jump to the next one. Yeah, and just before we keep going, let me double check. So we're able to see the screen into an issue before with that.
Um, I think we're good. We'll just see
Okay.
with everyone. If we have any problems, we'll hopefully see that in the chat. But yeah, chat, do speak up if you need us to zoom in or if there are any issues with the screen sharing at all.
But a couple of things we're looking out for with high availability is, we need to prevent or at least prepare for things like backend outages. So the destination that you're sending to may have a brief outage and maybe a network outage. How are we handling that? We know that in these environments, we have node restarts, collector restarts, there may be collectors going down or systems going down at any stage in the pipeline. And how do we handle it when we go through updates to those as well? So those are a few of the things that start to impact the environment, or things that we have to consider when we're building a resilient pipeline. So there are a few things that we'll talk about. We know we need load balancing. We need to handle against persistent storage failures. We need to be able to scale, and ideally we're doing that horizontally, and that we can also do that automatically whenever possible. And those are a few of the things, and we'll dig into each of those in detail. But the first concept that's really critical for understanding how do we build resilient pipeline with OpenTelemetry and make OpenTelemetry scale is this concept of OpenTelemetry as either agent or gateway, the OpenTelemetry collector specifically. So a lot of times when you start out, you may have gotten started with OpenTelemetry as the SDK that you instrument your code base with. And a lot of people start out, they send directly from their application to the backend. So they just put in the IP and you're good to go. And that is a great way to get started, but it is a really tough way to scale. So if you started with that instrumentation level, usually the next step is maybe you add a collector to the host, a way to offload that telemetry before sending. That takes the load off your application, but it doesn't solve that challenge of not having a central location to do the processing. So what the community has landed on as the standard architecture is this agent gateway model. And in this structure, we have the agents, and they are going to sit as close to the application or host as they can. And then the gateways, and the gateways are going to be typically going to be scaling out. They're going to be dedicated systems for processing telemetry as it goes through the pipeline. This concept, you have an agent for collection, normalization, and pre-processing, and then the gateway is for scalability. It's for any heavy processing that you need to do for routing, caching. But it's the same binary in both cases. And we'll talk more about how this, how we actually go about implementing this and building it out, and why we do it this way. So we mentioned this, we want to use an agent gateway architecture. Those agent collectors are going to run on every host. They can run as a sidecar. They can run on the node. They can run in their own VM. They can be pulling from applications instead of deployed directly on the host. But we want them to be close, right? Close to that application. And then the gateway collectors, they're going to be in a central location. We show this as in this example, it's simplified, and we have a load balancer in front of one group of gateways. Typically, there are going to be many, many of these, depending on the size of your organization. And those can be based on region. They can be based on your application type, depending on the business needs. But they're always going to be centralized. They're always going to be auto scaling if that's possible in your environment. And they're going to be receiving all of that telemetry from the agents. And when you have this structure, each layer can be scaled separately, and it can be scaled horizontally. And that's really the situation that you want for a pipeline. especially if you expect this to go to very, very high scale. If you're getting to petabytes per day, this is an architecture that will work at that scale. We do want to think a lot about this because we're going to use gateway groups. We want to load balance this at every point where we have those gateways, and that's going to allow you to expand horizontally. It allows you to manage those rolling updates, allows you to manage failover. We'll talk a bit about what it looks like to have resilience in those individual collectors as we get into some of the demos, but we need to, by default, the collector will handle in-memory storage. And so if you have a brief loss, the collector doesn't go down, it will retry, it will maintain that buffer. However, for protecting against failures of an individual collector, we need to have persistent storage. And so it's a key part of building in resilience to the pipeline, is adding in persistent storage for anything that's critical infrastructure. We're also going to talk a little about sending queues and how we manage those, and some optimizations that we can do, and even talk a little bit about what to look at to optimize further when you get to a point where you're scaling horizontally, but you're at scale and it's big enough that it becomes a challenge, and you want to optimize those individual collectors to reduce total CPU usage. We've got a few specific things just to make sure they're top of mind as we think about what we're doing and why we're doing it, what we consider for scaling. The first is, and this is really the reason that we pull a lot of the work off to the gateway. If you have an agent and it is very close to your application, and that for whatever reason has high resource utilization. Now, I don't want people to be overly concerned with this, and the collector is a very efficient process. However, you can have very high telemetry volume with a lot of processing, and if you have that running alongside a business critical application, you need to be aware of the processing that's happening there. So when we think about this, we want to make sure that we offload from that agent as soon as possible and try and limit any processing we're doing at the agent level, move that to the gateway. So to solve for this, we're going to be paying close attention to what the resource utilization of the agent is. We're going to batch. Early batching is something that will increase efficiency and is highly recommended in almost every situation. And we want to move any heavier processing to the gateway collector. So if we're doing a lot of processing on the telemetry coming through, whether that's for reduction or adding metadata or filtering out, routing, if it can be moved to a gateway, that's what we would always recommend. The next scenario we have is at the destination itself. So, we talk about at the agent, we move things to the gateway, but you'll frequently find, and one of the reasons people put a telemetry pipeline in place is to reduce costs, right? That is one of the challenges. But alongside that, just operationally, you can also run into issues with a destination that is unable to keep up with the amount of telemetry you're sending. Either that is simply limits to the bandwidth available. It could be network problems. It could be a problem with the service itself. We still want to reduce the likelihood of any data loss. And so the way that we solve for that is at every gateway, make sure that we have persistent queue configured, that this is storing to storage and not just in memory, that we have retries configured, and that we're filtering out data that's not needed or routing it to a separate destination. That lets you limit the amount of data, verifies that this is going to persist and that it's persistent over a failure or a back pressure that you may see. And we can size that based on what your requirements are. If you need to manage a 30-second uh, failure or connection loss. If you need to manage an hour-long loss, you can size a queue based on that. And then the last one is really we get to a point where as things grow and we know they can grow exponentially, at some point you're going to find that you're overloading a gateway. And this tends to happen, or you'll see this when you're starting out and maybe in an initial deployment, you have a fleet of agents, and then you have one single gateway, and you do that until you find that it simply won't continue to scale. Or you find that it goes down once and then you've lost telemetry. So this is one of the more straightforward things that we can solve for. It's because the majority of processors and stages within a collector are stateless. This can be straightforward and can be load balanced in a typical way. There are some exceptions to that. We'll call some of those out, but we also have ways to work around those. In general, you can scale a gateway out just like you would any other service. We use standard auto scaling principles, and we'll talk through those. But that allows you to scale at each one of these nodes, scale out horizontally, and gives you a structure. So if you look at all of these, the agent, the load balanced gateways, auto scaling gateways, that gives you the building blocks that you need to build a highly available, highly resilient pipeline.
Nice. Um, Now, once we have a clearer picture on uh, how it should look and all of the theoretical best practices on how you tend to set up high availability, we can start with a uh, very simple approach of how you would do it with Docker Compose, and also using Nginx as a load balancer, which is uh, probably the first way you're gonna set this up if you haven't set up high availability at all and you want to do a quick intro on, yeah, let me set up basically the gold standard that I can scale out horizontally to whatever I need without using something like Kubernetes. So let's say you have either VMs or you have a few VMs that you're using to run containers on. Um, so essentially what I do want to show you is a setup where we have an agent mode collector that's gathering some telemetry. Well, in this case, just generating telemetry itself, sending that off to an Nginx load balancer. We'll also do a brief demo on using the collector with the load balancing exporter, and then sending that traffic evenly, so distributing the load evenly to multiple gateway collectors that then send off to whatever backend you might want, maybe an OTLP backend like Grafana, maybe Datadog, or just maybe some other gateway collector you have down the pipeline. So yeah, to do that, I'm first going to jump in to a little Docker Compose file that I have right here. So this is just a Compose file that has all of these images, or basically this graph that we're showing here, that's just painted into Docker Compose. So we have the gateways, we have three specific gateways. They're all running the Bindplane distro for OpenTelemetry Collector, just because it's kind of nice to visually represent that in Bindplane for the demo. You could be running whatever OTel distro you have. Um, it's connected to Bindplane via OpAMP, and Mike will explain what OpAMP is in a bit as well. But the kicker here is that every single one of these collectors, they have a dedicated volume. And the key point here is that every collector has its own dedicated volume. And this is to enable the persistent queue that Mike just mentioned that we will be demoing in a bit as well. Then apart from the gateways, we do have an Nginx load balancer. So you can see right here is just a basic Nginx container. Um, and we have the agent mode collector right here that's generating telemetry. I'll be showing that in a second as well. And then we have just some external gateway that is a simulation of pretty much any OTLP telemetry backend that you might have. think of Grafana or whatever like that. And then to start it, just run this Docker compose up. I've already started it just for the sake of brevity. And what this would look like, just before I show you in Bindplane what this looks like when you're visually inspecting the collectors, is that the only config that you need to set on these containers running, specifically on the OTel Collector containers running, is the default is just a placeholder config. So something like this. So the collector itself just needs to start as a container. The management and all of the configs, they just get remotely pushed down to these containers from Bindplane via OpAMP. So via this connection to Bindplane. And this is essentially how that works is once I have the collectors started, dive, they will show up here in the Bindplane UI. Now, what does this really mean? Well, to get all of this traffic working or sending telemetry as I want it to, I need to create configs. And I've also just pre-created a few configs just to keep this demo a bit shorter, is for every one of these configs, right here we have the agent mode collector. So it is generating some telemetry and it's sending it to my the host name for my Nginx load balancer. So the kicker here is for you to know the host name of your Nginx load balancer. Because I'm using Docker, it's actually visible in my Docker Compose. So if I do jump back into my Docker Compose, and this is what my service for Nginx is called, and I've also set the host name here and the container name. So from this, I know which host name I have to put into the destination where I'm sending all of the telemetry from my agent mode collector. Um, Now to validate or just to make sure that we see that we have telemetry getting sent, this is a snapshot of the pipeline itself. You're just getting some logs that are generated and they're getting sent out to the destination, to our Nginx. Now, so how does the Nginx load balancer figure out how to forward this to the collectors, to the gateway collectors? Well, that's in the Nginx config. So I have this little config here, and it's configured for both gRPC and, so you can see gRPC, and for HTTP using the OTLP protocol. Um, and what it does here is that you can see that I've specified three servers, well, three host names. So these are the host names from my Docker Compose. And I've specified the OTLP ports for both gRPC and for HTTP here. So this is in the Nginx config. This is where I set all of the host names that I want my Nginx to load balance traffic against. And I can go back here and see, yeah, OTel Deep Dive Gateway 3. So yeah, the host names, they all match up and they are matching what I have in my Nginx config. So if I do jump over to the config that I have created for, again, OTel Deep Dive, for my uh, for the gateways, I can see here that the source is just OTLP, just a receiver basically for OTLP. So it's obviously going to listen for telemetry on ports 4317, so 4317 and 4318. So that adds up. So my Nginx is sending and load balancing traffic to these ports in my gateway collectors, and I'm using destination to send them to my external gateway. So this external gateway doesn't really matter specifically what it is. It can be an OTLP uh, backend for telemetry. It can be Grafana, Datadog, Dynatrace, basically anything you want. This example, this is just another gateway running in a separate on a separate host name in this sense. But the kicker here is that once I open up the processors and I look at the throughput, I can actually see that it is getting evenly distributed across all three of my gateways. So you can see it's right around 270, 280 kilobytes per hour across all three. Um, So we can specifically see that Nginx is actually sending all of this correctly and load balancing it across all three of my gateways. And that's actually pretty cool. Now, let's say I'm a bit cheeky and I want to kill one of those gateways. So we can just do doc post PS. Let's say I want to kill the second one. So I'll just do a doc post, whoop, if I know how to type, stop, whoop, stop, and I'll just stop the second one. Now, if I jump back to my agents and I go into what to look for my OTel deep dive, I can see that gateway 2 is disconnected. Okay, that's too bad. But if I look at the config and I go back to my config right here, um, sure, one of these gateways is now disconnected, so it might be broken, it might be overloaded. Maybe I don't know, but I still have two gateways running, and they're distributing traffic just fine. So I'm getting my high availability here because even though I have a gateway that goes down, or maybe I stopped it on purpose to update the agent version, whatever. I'm still getting throughput to my end destination. And now what's also cool here is what if I kill the external gateway? So let me go ahead and do a Docker compose stop for the external gateway as well. Oop, now we don't have anything. Actually, we don't have the external gateway running either. So if we do conk post PS, yeah, the external gateway is broken now as well. So this simulates exactly what Mike was telling you about. What if you have back pressure in the telemetry, your telemetry store or your backends? What's going to happen? Well, specifically for this one, it's going to be it's going to be stored in your persistent queue in the volume that I just mentioned. Um, but this is where it gets super interesting, and this is where I want to hand it back to Mike to do a bit more explanation. But before we do, just to give you a recap of the intro, the bare bones basics of doing load balancing, is you have in this sample three gateway collectors. They're running in parallel. You have a load balancer. It's distributing OTLP traffic. We suggest that you use Nginx or any other dedicated load balancer. If you really want to use the OpenTelemetry Collector's built-in load balancing exporter, you can. That's totally fine. So if you have an additional OTel collector like right here in this demo, you can use that. The specifics for that is that you would need to set up a custom destination. And what that would look like is right here. So you'd have to do a very similar setup to what you have in your Nginx config. You essentially you point it to the host names that you have for your gateway collectors. So if you're comfortable with setting up Nginx with this setup, it's not that different for the OTel collector's load balancing exporter. The only difference here is that this is not the preferred way we suggest you do it. The reason why this exists is because if you have very intricate trace spans or basically distributed traces in general, and you decide on doing sampling on traces, they can get lost if you're using Nginx. So if you really have super elaborate tracing setup, then you should use the load balancing exporter. In basically any other use case, you're better off using a dedicated load balancer like Nginx or whatever else there's available on the market today. Yeah, so the things to remember as well is that you have a persistent storage, so a dedicated volume configured in Docker. You're using unique persistent volumes, so make sure that every one of your collectors has a dedicated persistent volume because you need queue isolation. It won't work otherwise. And then you obviously again have failovers and rolling updates. So whenever a gateway goes down, you're ensuring that traffic continues. So yeah, I think we're ready for some more deep dives into specifically resilience, and Mike is your guy for that.
Cool. Yeah, it was a good setup. And so you saw a lot of the setup and how do we configure this and how do we make sure that a collector has all the components that you need for resilience. And so we'll talk a little bit about what we then need to do at the collector level. So the short is we need to make sure that batching is in place uh, in a number of spots. We'll talk about that. Make sure that we have retries configured correctly. Make sure that we have a sending queue, and then we make sure the sending queue is using persistent disk storage whenever that is a critical point in your pipeline, and that extends to both agents and also gateways. But I'll jump in and show exactly what that looks like.
Yeah, start sharing
And
so you can pull up the.
perfect.
There we go. It's like we've done this once before, so we're very in tune with changing the screen shares.
Feels like more than once.
Yeah, yeah.
Um, yeah, so you were just looking at this a second ago with Adnan showing how we spun up the telemetry generator agent. So if you think back to what I was showing earlier, we have the agent and gateway model. Right now we're looking at one of those agents. It's simulating some telemetry being generated, then sending to our load balancers. We have it configured for 2 right now, just for demo purposes. And this could be many agents with the same configuration, but just for simplicity, here's our pipeline. You jump in, you can see the data is flowing through. And we talked about a couple of things that we need to make sure are in place for at the agent level. One is always want to make sure that we have batching. In Bindplane, we can add that in here, but I'll show you what that looks like within the raw config as well. And we have some, intelligent defaults here. This is frequently going to be a good place to start. Run 8K, 200 millisecond timeout. This is configurable, and if you need to come back and tune it, then it's a place you look at after. But I wouldn't start with tuning the batch size. I would go with some of these defaults that people are using, and then see whether you still need to tune that further. So in this case, I'll add up some batching right after we ingest that telemetry. And then we'll look at what we have on the OTLP output. So we're sending to 2 places, collecting that telemetry, we're batching it, and then we're sending it to a gateway. And a couple of things are available on your OTLP destination. Things like compression, which is going to be enabled by default. But then the key pieces that we mentioned already are retry and failure, the sending queue, and the persistent queue. So Adnan set up storage, persistent storage that was attached to all of these collectors. That's used for this persistent queue. We look at this sending queue. This is what's the size of queue and how many consumers are there going to be. So how many of these can run in parallel. And then we have retry on failure for your initial interval if there is a failure, and then the exponential back off up to which point. And so this is, it's going to allow you to persist data through a failure, configure the size and time that you're willing to wait before giving up on a break within the pipeline. And that's all available within the OTLP configuration. So we have these, you can configure these by default, but let's look at the configuration to see. So here's the configuration that's applied to this agent and a couple of pieces that we want to dig into. So we know we added that batch processing with a standard size and timeout. We have some additional processors that are included based on the pipeline that was built here. And then we have for the OTLP exporter, retry and failure enabled, sending queue enabled, and we have this file storage extension. And this is a key piece. So you can have a sending queue in memory, but we want to make sure that this persists to disk. So we have the file storage extension configured to allow us to persist that to disk. So that was on the agent side, and to quick look into the gateway side as well. And again, now that we're on the gateway, we can, same thing with batching. And we may decide that at the gateway level, the batch size can be larger. But for now, I'm going to leave this as is. And I would say that if there is tuning, then we really want to consider doing that at the gateway level, because that's where it's going to scale out. Most significantly, you may want to be managing higher throughput and more processing. So I'll add the batch for now, deploy this to the system. And a couple of things that we really want to consider, and I'll throw this in, even though we didn't have a slide in the presentation, but just as we're talking about gateways and how we recommend optimizing these, there are a few pieces that you want to look at within those groups. So we were just looking at a gateway group. Typically, you can scale this on CPU and memory, just like you would anything else that you were load balancing. So you're really looking at what is the cache requirement that you need for persistent queue, and then to scale out what is the CPU max, memory max before you expand to the next one. What I wanted to mention was if you're really getting into tuning these and you're really looking at queue size, for example, the OpenTelemetry Collector exposes its own Prometheus endpoint and its own metrics that tell you exactly what's going on within that queue. And there are three that you're really going to be most concerned with. I would even say two. One is the queue size, and then one is the queue capacity. So those are two metrics that if you do need to get in and look at, are we running up against that queue barrier? You're going to see that with this queue size being greater than your queue capacity. Something to look out for. And if you do get into that deeper tuning level of tuning, that's what you're going to want to look at. So let me jump into a couple more, or feel free to take over control. And
Yeah.
But a couple of the items you talked about, with resilience, we want those agents to be as close as possible to workloads. Make sure that we grab the data and send it along, right? And with minimal impact on the host that it's running on. With the gateway collectors, we want to protect against any of those backend outages, any back pressure, any throttling, and make sure that we have sufficient buffer. So sufficient queue to allow for whatever the timeline is that we require in the event of an outage. We mentioned retry attempts, persistent queue, and batching as a core three concepts that we use within a collector to maintain resiliency. And then beyond that, it's really your standard load balancing best practices, like I mentioned. And that includes making sure those collectors exist in multiple availability zones. And you can follow the standards that you have throughout your organization for managing anything in a resilient way. So I'll kick it back over to you, Anand.
Nice. Nice. Yeah, this was perfect, and a perfect segue into showing specifically moving more into the production, I'm going to say production environment. So one thing is now once we understand what a basic setup with Docker, what it looks like, and that it's transferable, that knowledge is transferable um, to any VM setup as well, we can jump into a bit more of a complicated, a bit more production ready setup with Kubernetes, specifically because with Kubernetes, with its auto healing, auto scaling, auto magic, I'm going to call them properties. You don't need a dedicated load balancer like uh, like Nginx. You can have Kubernetes do it for you and also scale it for you automatically as well. So for this last demo for today, I do want to show you first what this demo looks like. The diagram or the architecture is it's essentially the same as the first demo. So we have agent collectors running as daemon sets. They have telemetry generators, so they're simulating application traffic or application workloads. We have a load balancer, which in this case is a Kubernetes service, so it's a dedicated resource, a service in Kubernetes. That is in turn scaling or specifically distributing traffic evenly across three pods running in a deployment that has a horizontal pod autoscaler. So these are a bunch of long, complicated words, but let me walk you through what that would look like in a demo. So first, let me jump into a bit of a kubectl command. So if I do a kubectl get all, and I want to get all of the resources I have in my cluster. So right here. So as you can see, I have a autoscaler, I have a deployment, I have a daemon set, and I have a bunch of services with a bunch of pods as well. I've also just pre-configured, pre-started all of this, so just so you can see what that all would look like both here and in Bindplane. But the kicker here is that first showing you the configs that I have, the configs I really need only boil down to my agent collector config and my gateway collector config. The external gateway here is just, I just wanted to simulate that stuff is actually happening and that the gateway is actually load balancing and sending all of the telemetry I'm generating from the agent into the external gateway. Well, outside of the cluster. This is a totally different cluster than the one I'm running these two in. So what does that look like now? So if I jump into the agent collector specifically, again, it's just a telemetry generator. And I'm sending to a Bindplane gateway destination. Now, the destination here is the DNS name or the DNS resolved host name of the service itself. Now, if anybody knows about Kubernetes, you know what this is. If you don't, I'll just say this is the name of the service. This is the name of the host, the namespace, the service itself, and then cluster.local. That's just the internal Kubernetes naming. And I'm sending this to 4317 just because that's where all default OTLP gRPC traffic goes to. Um, Now, with this setup, this means that I'm going to be configuring my collector, my gateway collector, sorry, config to receive OTLP on the default 4317, 4318. And I'm sending to an external gateway that's whatever host name I have here set up for my second cluster that is receiving all of this telemetry. So what does this really mean now? Is that once I'm setting this up, I'll first go ahead and create my configs. And this is how neatly integrated we've made this with Kubernetes inside of Bindplane. If I want to deploy an agent collector, I'll go ahead and select Kubernetes. I'll select node. I'll select my agent collector telemetry generator. I'll go ahead and click OK. And this is the manifest I get. That's it. I can copy this manifest. I can go into right here, I have a file with my agent collector, paste that in as I've already obviously done this just to be as brief as possible. And I'll go ahead and apply it. I can apply it with agent collector, and this is going to say up and running. And that's all the magic there is. And here, of course, I have my connection. And of course, I get every connection here. So this is all the magic. This is going to run as a daemon set. So let's just jump back into right here so you can see that it is, if I know how to spell daemon set, it's going to run as a daemon set. So I'm going to have one agent mode collector across every node inside of my cluster, across however many nodes I have. It's going to be dedicated for that node. It's going to collect all of the application workload traffic, the telemetry from all of the apps on that particular node. Um, and that's how neatly integrated it is. But it's also very neatly integrated into setting up a gateway as well, because if I select the gateway here and I do my gateway collector with an HPA, that's it. Again, I get my manifest. Can also select, I can also make it a stateful set if I want, but I'll just keep it a deployment for the sake of keeping this demo as simple as possible. Now, if I do, I can also just paste this in, save it, and I'll run the same apply for my gateway collector. Again, it will restart. I can also just do a quick get, and I can see that I'm getting all of my gateways. They're actually the gateway collectors pods are getting started. And again, I get the notification that they're started and connected to Bindplane. And again, I get them all running in Bindplane. If I go to my configs, I can see, yep, I have so and so many agents running for my gateway collector. And that's it. So this is we're immediately getting all of the benefits we talked about so far with the Docker, the manual setup with Docker, all of the configs that Mike just talked about with the storage, so getting persistent storage, getting all of the retries set up, all of that in the collector config part set up correctly. You get just everything pre-configured with this manifest. And if you take a second to scroll through the manifest, you'll see, yep, I have my volumes all configured. I have all of my OpAMP configured. I have my HPA configured. So if I want to scale to 4, I can just say, I'll just make this 4. I'll go back into my kubectl, I'll supply this again, and it's going to say auto scaling configured. And if I jump back into Bindplane and go into agents, I'll see in a second probably. Give it a second to reload. Hey, there we go. So now I have 4 gateway collectors running connected to the gateway collector config. It's that's how, that's how fast that is. If I don't like it, I can just go back and say 2. I can go ahead and apply the same thing. It's going to go back to 2, or I can just do the ye old manual Bindplane, no, sorry, kubectl scale deployment, set it to 3, whatever. So now if I look at my pods, now I have 3 pods for my gateway collector. So, and then of course, if you give this a second to reload, it's going to figure out that yeah, I have 3 collectors right here, gateway collectors running with that particular config. Um, and yeah, so the point here is that you're using the native setup from Kubernetes. So you have a deployment that has pods that you can scale however many pods you want within that deployment. You're using the horizontal pod autoscaler to basically figure itself out. And the way it does that is the autoscaler has a CPU utilization type resource right here. So if the average goes above 60, it's going to scale up. So I think this is way easier than me looking at some metrics, just having it figure itself out. I bet the people that wrote Kubernetes are slightly better engineers than I am, so I'm just going to go with that. Um, and that's the gist of it. And then of course, instead of using Nginx, a dedicated Nginx or whatever load balancer you want, you use the service that's provided to you within Kubernetes. So again, You have one dedicated, so where is it? Right here, the cluster IP service, so this guy. This is a dedicated service for you that's going to load balance traffic across all of the pods in for the deployment. So for specifically this deployment that it's connected to. Um, and again, it just works, and it just works very well. I don't like using the word just, but I like when it just works. And yeah, so for the sake of, I'm gonna be respectful of your time. I'm gonna stop with the demo right there. And yeah, let's just jump through a quick recap of this last Kubernetes demo. So we're on the same page. First and foremost, the agent mode collector is running as a daemon set. So it's running as close as possible to the application workload. You have specifically one across every node in your Kubernetes cluster. It's going to use the buffer for retries and queues. So that's all essentially enabled by default within Bindplane when you set that up. So if we go into the agent collector right here, the advanced settings that Mike just showed you, that's all going to be enabled by default. Same for the gateway deployment. It's going to have all these enabled by default. You also specifically run the gateway deployment, well, the gateway collector behind a service, a cluster IP service. It's scaled because it has a deployment with at least two pods. And then you use the horizontal pod autoscaler to auto scale between 2 and 10 in this sample, but you can, of course, set this for exactly what you need. Then use Bindplane for auto-generating all of the configs for the agents, or you basically set them, configure them, and then automatically push them out to your collectors. It's really makes it super easy to set all of this up. And by using Kubernetes, it's also resilient by design. So this is a very production-ready HA pattern in Kubernetes that will very easily scale horizontally to quite a big load. So it's not something you need to worry about once you set this up. And yeah, let's just do a quick recap of the architecture. It's essentially the pattern is the same. So you'll, of course, stay with this identical pattern using agent gateway collectors, using a load balancer, and scaling the traffic evenly across all of your gateways. The only thing that changes is the platform you use, and this, of course, ends up being a question for your organization, how you internally want to do it, how you're running it right now. But the only thing I want you to really take away from it, from this whole demo is that the pattern here is what's important. If you set that up correctly, you're going to enable high availability without any big issues. And yeah, the architecture takeaways I want you to remember is to get your high availability, you need to make sure you have scaling, failover, and persistence. You also need to make sure that you're using the agent gateway pattern because it is quite literally the backbone of all of this. It's the foundation of high availability. And then at scale, you can also use Bindplane to basically manage all of your collectors. So you don't really need to look at any YAML files. You don't need to change a YAML file and hope and pray it works. You see the telemetry throughput, the snapshot of all of your telemetry flowing through inside of Bindplane. So it's much easier to actually know what's happening. And for a quick recap, I do want to hand over back to Mike to chat a bit about why and how Bindplane does that communication with the collectors. And it's a thing called OpAMP.
Yeah. I love the Kubernetes demos. I think that's, if it fits within your environment, that's the way to do this and to scale out a collector group. But yeah, let me jump into this. And with the Open Agent Management Protocol, this is something that we worked on to as part of the OpenTelemetry project to design a remote configuration protocol to manage OpenTelemetry collectors. Not limited to OpenTelemetry, but that is the focus now. And the reason behind this is, with the telemetry pipeline and with the telemetry collection in general, there is a strong need for this ability to manage that and do that at scale. Things like remote configuration, actually looking at the collector's own telemetry. So like I mentioned before, and you can do in Bindplane, you do want to know what is the queue size, where are we at, are there issues with the pipeline throughout, and OpAMP allows us to capture that. Uh, yeah, that's a good one. That gives you a little bit more of a sense of what's available there, and even the metrics that are associated with those. But OpAMP, we've developed this and worked with other teams to incorporate that into Bindplane itself. And so that's how we're able to do that from within the Bindplane interface. It's connecting to individual agents, managing those agent upgrades, including secure auto upgrade capabilities, and handling all the credential management at the same time. So pretty critical. And I think as your telemetry pipeline grows, something or a solution like that that is able to manage and control them becomes increasingly important for you. So I'll pause there. I know that we've got just a couple minutes, but happy to answer any questions if there are any that come up before we have to wrap up.
Yeah, it's a great moment to take a break and see if you have any questions. We did have a few. We managed to get those answered asynchronously while we were doing demos, so that's pretty cool. Yeah, we can take a second to pause here in case you have any more questions. But also, if you can't think of anything now, but you end up having in a bit, or once you rewatch the recording, do jump into our Slack. You can pop into our Slack community. Go ahead and ask there. We're all pretty active there, including myself and all the rest of the team, both support and product. So um, yeah, I'm pretty happy with those demos. We did have the demo gods with us for these three. It didn't have any major issues, which
Pulled it
is
off. This is
I
off.
always
Yeah.
have problems with whatever container demos I do.
Mm-hmm.
Yeah,
Can
that's good.
can you deploy Docker containers in different custom networks?
Um, do you specifically mean having them connect to Bindplane? Because if so, the only real thing you need to do is have an outbound 443 port. Because the way OpAMP works is a collector would connect to Bindplane from the inside out. So you only need to have an inbound or actually an outbound firewall open for port 443. And then since the collector establishes the connection, it's a WebSocket. So because it's a WebSocket, once it gets established from the inside, it just stays open. So that's why you get so one thing that it's really cool there is that you could probably once I was showing the install. So let's say this one. I was showing the install. Once the collector actually gets installed and starts running, it just automatically updates this little UI portion right here. And that's because WebSocket magic. Okay, got another one.
Elaborate
Can
on
you
the Terraform
elaborate?
provider, what parts it could do. It's done this demo.
I haven't touched Terraform in a minute. I'm not really gonna lie
We
there.
so maybe it's referencing. We do have a Terraform example of deploying Bindplane. So we have multiple versions. We have Terraform, or we have a SaaS version of Bindplane that's available. But for Bindplane Enterprise, we also allow you to deploy that internally or within your environment, and have multiple Terraform solutions there. Probably more details in there than we can get into here, but happy to take that one offline.
Yeah, sure. I mean, Miles, you can pop into the Slack community and we can just start a thread because we have a bunch of people in the product team that are probably more knowledgeable than I am and can be of more help there. So
Excellent. I think that's time.
Yeah.
Again, any
On the hour.
questions? Yeah, feel free to shoot them our way afterwards. Really appreciate everyone joining. It's always a fun topic for me and great demos.
Yeah, I had a lot of fun. And yeah, we'll make sure to upload the recording to YouTube by tomorrow. And yeah, we'll shoot over an email with the recording for you guys so you can check in and yeah, rewatch anything you thought was interesting. And with that, until next time, have a great time and yeah, see you next month, hopefully.
Thanks, everyone.